Here in this video, we're going to look at solving quadratic expressions by the method of square roots. Now, what you want to do is you want to, just as if you're solving any equation, you want to isolate your variable, and then you want to proceed your way into solving. And so if I'm looking here at this first question that we want to solve, we have m squared is equal to 36. Well, the variable here is already isolated, where the only unknown variables on the left is equal to a number on the right. In this case, to get it to be m equals, I would have to take the squared root of both sides, because the squared root is the inverse of me squaring, which they will undo one another. Now, we know that the square root of 36 is 6 because 6 raised to the second power makes 36. Now, the square root of m squared is not m. Anytime, and that's kind of counterintuitive, you say, wait a minute, well, 6 squared makes 36. The square root of 36 is 6. Why doesn't that work for a variable? Well, because a variable represents an unknown quantity, and anytime you apply an even-powered root to an even power, or in this case, the square root to something being squared, it will create the absolute value of whatever that variable is, in this case m. So this the absolute value of m. The reason why this is the case is because, think about this, there exist two numbers that I could square to make 36. I could square positive 6, or I could square a negative 6. Now, let's look at a way to check our answer here by using Desmos. Now, what you can do is you can create two graphs. So I can create the graph of y equals m squared, which I'm just going to use an x. So I got y equals x squared, and then y equals the right-hand side, in this case 36. We'll solve this system of equations graphically, find our points of intersection, and the input, or the x values, are our answer. And you see how we got negative 6 and positive 6. All right, so here we go. We new problem. R squared is equal to 8. We want to solve for values of r, so we take the square root of both sides here. The square root of 8 is not a whole number, so we'll worry about that here in just a second. So I'm going to write the square root of 8 is square root of 8. The square root of r squared makes the absolute value of r. And so now let's worry about go through and simplifying that radical. So the square root of 8, well, 8 is 4 times 2. 4 is my perfect square, so the square root of 8 is equal to the square root of 4 times the square root of 2, which the square root of 4 makes 2. So what we have at this point is that r could equal positive 2 square roots of 2, or r could equal negative 2 square roots of 2. And now we can go through and we can check this graphically with Desmos. All right, so I have the graph y equals x squared, the graph y equals 8, and we look, and I also typed in the square root of 8 to show the decimal and 2 roots of 2 to show that we simplified the radical correctly, and we should see that the parabola y equals x squared intersects the blue line at those values of 2.828, and I see the positive one and the negative one, so we did it correctly. All right, next problem. This time we have 6a squared is equal to negative 54. Well, first move in solving is to isolate the variable you're solving for. So I would come here and I would divide both sides by 6. And that's going to give me a squared is equal to negative 54 divided by 6 makes negative 9. Well, from here, what I would do is I would, just like we did before, take the square root of both sides. And we're looking and we have an issue. The square root of a negative number. So I'm asking myself, well, what number times itself will make a negative value? And the answer is no number, no real number can be squared to make a negative number. Now we have imaginary solutions, but that is more along the lines for an Algebra 2 course or Math 2. So anytime I'm taking the square root of a negative value, what I would write here is no real solutions. And now let's go into Desmos and see what that means graphically. All right, so I have the graph y equals 6x squared graph, and I have the graph y equals negative 4 plotted as well. And you look, now in the previous two examples, the two curves intersected each other. Notice how these two curves do not intersect, which means that there is no solutions to the system, which is why we ended up with no real answers. All right, One more example here. So I want to solve for values of p. We need to isolate p, so we're going to move any adding, subtracting first. So I'll add the 5 over. We end up with 49p squared is equal to 16. We'll divide both sides by 49 here. And we're going to wind up at this stage with p squared is equal to 16 divided by 49. Now we would want to take the square root of both sides. The square root of p squared, so I come over here, the square root of p squared makes the absolute value of p. The square root of the 16 over 49. Well, the way that works is you would take the square root of the top number, so it would be the square root of 16 divided by the square root of the bottom number. Well, the square root of 16 makes 4, the square root of 49 makes 7, which means that we should have two possible values for p. P could equal positive 4/7, or p could equal negative 4 over 7. Now let's go compare those answers in Desmos. All right, so I have y equals the left side of our equation, y equals the right side of our equation. We said that we should end up with answers of positive or negative 4/7, so I have the decimal for us to compare to. And we click on the two intersections, and we confirmed our answer because we have negative 0.571 and positive 0.571.